Ladies and gentlemen, welcome back to Basement Machinist. Today we're going to talk about lathe milling attachments. More specifically, milling attachment for my lathe, which is a 9-inch South Bend Model A. Now there's many options actually that you can choose. I'm not going to go over all of them. I'm going to go over probably the three more popular choices. The first one being the palm grin milling attachment. This milling attachment is pretty much universal. It can be used on any lathe. However, this is probably the worst option you can go with, and we'll go over why it's the worst when we head over to the lathe in a few minutes. The next option is, of course, the South Bend milling attachment. Now, this milling attachment, you're going to have to search eBay and maybe Craigslist. The price ranges anywhere between $130 on up to close to $400. I've seen them go. So, if you can't find one for cheap, then that might not be a very good option for some people. It certainly wasn't for me. The next option, the option that I chose because it was the cheapest, and as to use a vertical mill slide. Now this particular mill slide is marketed for the MacLeod lathes. So if you have a MacLeod lathe, you can get one of these. It should be a direct mount, and you can get to milling. Now this particular slide, we'll call this the table for lack of better words, is about 5 inches long and about 4 inches wide. And one of the biggest selling points for me was that it had T-slots, so I can mount whatever kind of vise I want to it. And then I also have the option to use the T-slots with toe clamps if need be. Now, judging by the length of the screw, you have little less than 4 inches of travel, which should be plenty for any kind of milling that you would do on a lathe. Now I did clamp this in my vise and checked it with my dial gauge to check this graduation dial here, and I have no idea what this dial is supposed to measure. It certainly does not measure inches. One full revolution will move the table 76.5 thousandths, which is kind of an obscure number. But anyway, I guess it could be reading metric. I don't have any way of measuring metric accurately, at least. So, like I said, it could be metric, but it certainly isn't imperial. So whenever I use this to make adjustments, I'm going to have to put an indicator on it to make the adjustments. Now, since this is marketed for, or made for, the MacLeod lathes and not the South Bends, you're going to have to do a little bit of work to get it to mount. So let's head over to the lathe and see what it takes. Alright, now that we're over here at the lathe, let's talk a little bit more about that palm grin vise. The way that it attaches to the lathe is it attaches to the top of the compound using the lantern tool post. On the back side of the attachment there's a fork. Now I'm going to use my wrench as an example. The fork goes around the tool post, and then you use a piece of stock in here and then clamp it down with the screw, and that's what holds it down onto the mill, or on the lathe rather. Now this is why I'm saying it's the worst option, because this isn't a very rigid setup. Everyone knows that the lantern tool post is not the most rigid thing in the world, and when milling, there's a lot of forces that are generated, and you're relying on this piece of stock, the forks of that milling attachment, and this T-nut. Well, it's not really T-nut, but we'll call it that. And this T-nut to take in all those forces. And when you, if by chance that your cutter decides it wants to grab or pull, then all that weight's going to be put on your lantern tool post and into these ledges on your T-slot, and could potentially break off these ledges of the T-slot on your compound. And then you're either going to have to remake one or try and find one on eBay somewhere. And that's the main reason why it's not the best option in the world. I guess, I mean, they're still being made, I think. So obviously there's a market for them. People are using them. So I guess if you're making light enough cuts, you don't really have to worry about it. But the way that I'm going to mount my slide is in the same fashion as the South Bend ones. So let me pull the compound off, and let's see what it's going to take. Alright, my plan is to mount the mill slide directly on top of the cross slide in the same manner that the South Bend milling attachment does. And in order for me to do that, I'm going to have to remake this stud, for lack of better words. And this angle here is 60 degrees, and I've used a piece of high-speed steel to make a form tool so that I can cut that angle. Then I'm going to drill and tap it for a 1/2 inch 16 bolt, and bolt it directly to the bottom of the mill slide, and then use this hole to mount it to the cross slide. And this is the same way that the South Bend attachments mount as well. And this way it's a lot more rigid than that palm grin option, and there's a lot more surface area for the mill slide to clamp down onto. I got my stock in the chuck. I've already got it faced off. Now we're going to turn down the perimeter to 1 inch 371 thousandths. Should be my final pass. Unfortunately, I don't have a 2-inch micrometer, so this will have to be close enough. Okay, what I'm going to do now is I'm going to use my grooving tool to cut a groove on that flat surface in that angle. That way I'm not relying on my forming tool to have to make that full plunge cut. This will relieve some of the excess tool pressure. Now I've already got the tool zeroed on the face and also the outer perimeter. So we need to move in 406 thousandths. And we'll lock the carriage. And then we're gonna, the full depth is 156 thousandths, but I'm gonna stay just shy of that so that I can make a clean corner with the forming tool. Alright, I stayed just shy of the full depth, which is about 154 thousandths, I believe is what it was. Alright, now I've got my forming tool in, and we're going to plunge cut this 60-degree angle. Now you want to make sure that the stock is tight in the chuck, because if by chance this forming tool grabs, it's going to yank your stock right out of the chuck and going to ruin the work. And use plenty of oil. Alright, and that's all there is to it. Alright, next we're going to drill and tap for a 1/2 inch 16 bolt. And the tap drill size is a 27/64. Alright, now we'll set up our tap. Okay, unfortunately I don't have a tap follower, so I'm just going to be using the dead center in my tailstock. Alright, we finished tapping the hole. I've countersunk it, and now we're going to part it off at a 1/2 inch. Alright, here it is. It's relatively easy. Just facing, drilling, tapping, and then using that forming tool that I made. Next we need to mount it to the slide. I've already taken the table off in preparation for this, but it already has 2 holes in it, but they're offset from center. So what we need to do, I've already got it centered marked. We need to drill a clearance hole for the 1/2 inch bolt so that we can bolt it onto the slide. Now this bolt is also a little long, so I'm going to have to trim it. Alright, we're all set up here on the drill press. And we're going to drill that hole for the mounting bolt. And that'll do it. Alright folks, I got it mounted to the bottom of the slide here. The bolt is a little bit long, but it's not going to interfere with the cross slide screw. Let's put it on and see how it fits. And she's locked up tight. There's clearance for the table to slide down. I can go up. And about halfway through the screw, the center of the table is about center line with the spindle. So I'm quite pleased with that. Let me get this indicated square with the spindle, and then we'll indicate it up and down and see how accurate it is. Okay folks, hopefully you can see the dial. There's not too much glare, but I've got the table square with the spindle, and I've got the indicator set so that it'll skip over the T-slots. We're going to run the table down, see how much run out there is, or not run out, but see how far the tram's off. Now it's fluctuating a little bit because I'm moving it with the screw. Has a little bit of a flex to it. There's a T-slot. Now we're back up at 0. Alright, so over 2 flats of the table, that's roughly about, well, let me find my ruler. It's roughly about 3 inches of travel, and it was only out about a 1/2 thousandths throughout that whole area. You know, for a homemade job, it's pretty good, and for a cheap table from India, I'm quite pleased with that. Anyway, that'll do it for this video. I thank you for watching Basement Machinist. I'll see you next time.